Hello, welcome to Surpac tutorials. My name is Kobe. In this tutorial, we are going to learn how to create a geological database in Surpac. One may ask what a database is. A database generally may be defined as an organized collection of data, and so therefore a geological database may also be defined as the systematic collection of drill hole data. Drill hole data is the starting point of all mining projects and constitute the basis on which feasibility studies and all reserve estimations are done. And the purpose of drill hole data is to determine where the ore body is located and to populate a block model with constraints, accurate grade and attributes. Surpac uses a relational database. When I say relational database, it's a database that has a collection of tables of data items, all of which is formally described and organized according to the relational model. And in creating a geological database in Surpac, the database can contain 50 tables, and each table can have a maximum of 60 fields, so we should take note. Now, there are two ways of creating a database in Surpac. One is creating it from raw drill hole data using the Surpac, and the other is connecting to an already existing database, maybe a Microsoft Access database, and it is also known as mapping the database. In this tutorial, we are going to create the database from raw drill hole data. Alright, as part of any mining project which usually commences with exploration, it becomes inevitable and very relevant to gather information about the drill hole program. So when a drill hole program is executed, the relevant information gathered include the color information, the survey, that's the downhole survey, the geology and the assay. In creating a geological database, one requires two major tables, the mandatory tables and the optional tables. The mandatory tables are information about the color of the drill holes and the downhole survey information about the drill holes. The optional tables include the assays and the geology. In the build-up process or creating a geological database in Surpac, a translational table will be added to the mandatory tables, making it 3. And as the build-up process continues, a styles table will also be added to the database, in addition to the optional tables, making it 3 tables. So in all, we are going to have 6 tables to create the geological database from. Alright. So I will create a rec directory and bring my CSV files, that's information about the drill hole data, into them. I have the color, survey, geology and assay information here. We'll go through them one after the other. I'll begin by explaining the color table. The color gives the location of the hole in space. That's the actual position of the hole in reality. So in this file, we have the hole ID, the northings, that's the Y coordinates, the eastings, the S coordinates, the reduced level, that's the elevation, the maximum depth at which the hole was drilled, and hole type. I also have here the survey. When a drill hole program is executed or holes are drilled, there is an activity called the downhole survey, and in this activity, a device called the reflex is descended into the hole to take readings of the dip and azimuth. And these readings are plotted in the reflex software to show how the actual hole in the field deviates from the plan. So when the device records the dip and the azimuth, it will be plotted in the software, and based on the dip and azimuth readings, it will plot it. The original hole or the planned hole will also be plotted, and the deviations will be revealed. Okay, so in this table we have the hole ID, the depth, that's the downhole survey depth, the dip and the azimuth. The dip is the horizontal inclination of the hole in space. That's the angle which the drill hole makes with the earth surface. Usually has value between 0 and 90. It is negative when it's below the earth surface and positive when drilling underground. The azimuth is the compass direction of bearing from the north and has values between 0 and 360. So looking at this file, the hole ID 1, we have at downhole survey depth 0. The dip that the reflex device recorded was negative 45, and at the end of the hole 82.5. The dip that the reflex recorded was negative 43.5. So this will be plotted in the reflex software to show how the original hole That's the actual hole in the field deviates from the planned. Okay, so we go to the assay table. When samples are retrieved from a drill hole, they are taken to the laboratory for metallurgical tests or assays to be run on them so that the average gold values will be reported. The metallurgical assay or test may be the fire assay or the black, that's the bulk leach extractable gold method. So in this file we have the hole ID, sample ID, meter from meter to the average gold values and the sample type. Then we go to the geology. When samples are obtained from a drill hole, it is the honors of the geologist to record the information about the samples, and the relevant information that may be gathered include the minerals in the samples, the lithology, the redox or weathering state, the moisture content, the sample recovery, and so on and so forth. So here we have the hole ID, meter from meter to the redox and the lithology, simple table. Alright, so all that we have to do is to create a rec directory and bring these CSV files into them. So I will create a new folder and give it a name, database. I will set as my rec directory. Then I'll copy the files, the CSV files, and bring them into the rec directory. Okay, so here they are. So we'll begin by creating the geological database from the information gathered from the drill holes. This is Surpac's default profile. We will set our profile to geology database so that the menus and the tool icons for geology database will be displayed. I will right click here, go to profiles and select geology database. And the menus and tool icons are displayed for geology database. Perfect. So we begin quickly. Go to database, open new. If you already had a database in the rec directory, we'll just click the drop down to select that, but we do not have any, so I will just give it a name, say new database. And I'm to confirm the name of the database, as you can see here, new database.ddb. The .ddb is the file extension for geological database in Surpac. So it's either I press apply to continue or I cancel to re-enter the name. I would want to maintain the name new database, so I'll click apply to continue. So this is the name of the database and the database type. As initially discussed, Surpac connects to so many types of database, such as Access, Paradox, Acquire, Infusion, and so on and so forth. So we click the drop down to see the list of database types that we have. We have Paradox, Paradox 5, ODBC is the Open Database Connectivity. This is General Access, and these are two different versions of Access, 97 and 2000. For the purpose of our work, we are going to choose General Access. Here we have stored and calculated. When stored is selected, it tells Surpac that we have preset some coordinates, or we have stored some coordinates that we want Surpac to read from in the calculation of the Y, X, and Z coordinates for survey and samples. But we have not preset or stored some coordinates, so we will select calculated. And when you select calculated, it tells Surpac that you do not have the Y, X, and Z coordinates for the survey. Thus, for the downhole survey activity, it is required that we provide the coordinates at which we do the survey, the depth at which we do the survey. But neither the reflex device can provide us with those coordinates, nor can we go into the hole to bring out those coordinates. So we will select calculated so that Surpac will do the calculation from the color table. Likewise, the samples, the depth from and the depth to, that's the interval at which we take the samples. We are supposed to provide the coordinates for the samples, but we do not have them. We want Surpac to do the calculation from the color table, which possesses our coordinates in reality. So we will choose calculated, not stored. So I'll click apply to continue. And on this form, I'm to load the optional tables. Surpac accepts 3 types of optional tables as we initially discussed. The optional tables are the assay, and the geology. Okay, but the type which the optional tables are, we are to provide in this on this form. So as you can see, we have the name of the database, the type of the database which we chose to access, and the mandatory tables, color, survey, and translation. We have only these two, color and survey. As I said, in the build-up process, Surpac will add the translation table, which is used to translate numeric codes. Okay, so all that we are supposed to do is to add the optional tables, which are the assay and the geology. All right, so we have assay here. Right click and add another for geology, and we go to the table type. There are three types of optional tables. As I said earlier on, we have interval tables, point tables, and discrete tables. Let me click the drop down for us to look through the list. Interval table requires data at an interval. That's the depth from and the depth to, usually associated with downhole samples. The point table also requires the point to, that's the depth to at which you take a value or you record a reading, and is usually associated with piezometric readings. For instance, if you are taking the level at which the meniscus of water has dropped down to in a measuring cylinder, you take the depth to value. So that's a point table. And we go to the discrete table. The discrete table requires data or the coordinates of a point in space, usually associated with geochemical sampling. That's for a stage like soil sampling, the preliminary stage, where you take samples at designated points. It is required that you provide the y, s, and z coordinates and maybe append a sample ID which may be unique. But looking at our assay and geology table, which we gathered from the drill holes, we have meter from and meter to, indicating that it's an interval table. Likewise, the geology table, we have meter from and meter to, so they are all interval tables. So we have to select intervals for the table type. Now I go to the time dependent section. When you check a time dependent box, it means that with time that value will change. For instance, if I check the box for the assays, I want to tell Surpac that when samples are retrieved from a drill and taken to the lab, the average gold values that are reported will differ from when taken to a different lab. But when you take a samples to a different lab, the gold values that will be reported will not vary much. Even if there will be a difference, it will be some decimal values, and that difference may represent a nugget effect. Likewise, the geology. The rock type in the ground will continue to remain in its natural state, unless maybe acted upon by some deformational processes or some external factors such as temperature and pressure. Otherwise, by nature, that's how the rock is in the ground. So if the rock in the ground is phyllite, it will continue to be phyllite because that's by nature how the rock is. So no need checking the boxes for the time dependent. I'll press apply to continue. And on this form, I'm to load the fields for all the tables. Now let me use the color to explain. We have field, type, nulls, index, length, number of decimal places, low bound and high bounds. I will explain these sections one after the other. I'll begin by explaining the field. Let me use the color to explain because we are on the color tab. These are the fields. This is the table, that's the header of the table, and these are the fields. The hole ID, the northings, eastings, elevation, maximum depth, and hole type are the fields. Then we go to the type of field. Surpac accepts about 7 types of field. In creating a geological database, I'll use this drop down to explain. So we have character field. Character field refers to numeric values and letters which is stored as text. Let's look at the color table for instance. When you look at this whole ID, this consists of alphabet and numbers stored as text. So this is a character field. Numeric values and letters stored as text. Alright, then we go to the Boolean. The Boolean refers to true or false values. That's a value which is either true or false. We do not have any, so we will not bother ourselves with that. Date time also refers to the date at which a drill hole program was executed or a particular drill hole was drilled. So you can add it if you only have it in your data or your CSV file. The duration also refers to the time, that's the number of years or months at which a drill program took place. The integer also means numeric values with no decimal places, and the rel refers to numeric values with decimal places. So take note the difference between the integer and rel. Memo is just a short piece of information that you can add to a database. Okay, so that is it for the field type. Then you go to nulls. Anytime a box is checked for a particular field, it tells Surpac that it should report that field as blank. For instance, if I check the null box for the y coordinate, I want to tell Surpac that I don't have it, so when it gets to that field, it should fill that place as blank. Alright, then I go to the length. The length of a field is the number of individual characters in the particular field. For instance, when you look at the color table, we have 1, 2, 3, 4, 5, 6, 7, 8. Together with the hyphen, we have 8 characters. So it is the number of individual characters for a particular field. Alright, then the number of decimal places, you can adjust it to suit your preference. We have the low bounds, which is the lower limit, and the high bound as upper limit. So we'll begin by completing the fields for all the tables. So the color, survey, translation are the mandatory tables. Styles, assay, and geology are the optional tables. So we'll begin by filling the fields for the color table. Now the whole idea, will enter a character length of 30, even though it was 8 when we counted it. For convenience and to be on the safer side, I'll enter a longer character length so that as time goes on or drilling continues throughout the lifespan of the man, and these CSV files are edited, I wouldn't have problem importing data from the CSV into my database. So I will enter a longer character length of 30. Then here I will enter 15. Maximum depth 15. Then we get to the whole path. As you can see, the box for the null section has been checked for the whole path, indicating that if you do not have it, Surpac should provide that field as blank because we do not have it. That's why Surpac has already checked the null box. And even looking at our color table, we do not have any field called the whole path. It's rather whole type. Okay, so we'll not worry ourselves with the character length. You can adjust the number of decimal places to suit what you want. So aside these mandatory fields, if there are other fields in our color table, we just bring them to the optional fields. So let's have a look at the color table. We have the whole type, and it's a character field. That's alphabet and numbers stored as text. Okay, so I will enter that one, the optional field, whole type, and it's a character field. I will enter a longer character length to be on the safer side, and I will choose the mixed case. If you choose lowercase and as time goes on someone enters an uppercase characters, you have problem loading or importing data from your CSV. Alright, so to be on the safer side, you choose mixed. Then we go to the survey table. Survey table, I will enter 30 for the whole ID because whole IDs are usually longer. I will enter 15 for the depth, a downhole survey depth. And as you can see, we have y, x, and z coordinates. We do not have these coordinates as initially discussed. We want Surpac to calculate the coordinates from the color table. That's why we chose calculated in the initial stage. So we will check the boxes for the null section for Surpac to provide those fields as blank because we do not have them. Then I'll enter 15 for the dip, 15 for the azimuth. Let's see if we have other fields aside these mandatory fields. We'll bring them to the optional field section. We have depth, dip, and original azimuth. Perfect. So we are done. Translation and styles will not bother ourselves with that. Surpac will do his own arrangement. The styles is required to display the colors of the drill holes in graphics, and the translation is used to translate numeric codes. Okay, so I'll go straight to the assay. Then I'll enter a character length of 30, a sample ID of 30. As you can see, the box has been checked. The null section has been checked for sample ID. So that means if there is no sample ID in our assay table, Surpac will report that field as blank. That's why the box has already been checked. And looking at our assay table, we do not have some areas we may not have a sample ID due to errors that some technicians are bound to. So you have to check the box to tell Surpac that if by mistake you do not append a sample ID, you should report that field for the sample ID as blank. That's why the box has been checked. Okay, then the depth from our enter 15. We do not have the y, x, and z coordinates, so we want Surpac to do the calculation from the color table. So we will check the null boxes for Surpac to provide those fields as blank. Then I'll enter 15 for this. We do not have the coordinates for the two values. Then we will bring the optional fields aside these mandatory fields into this section. Let's look at the assay table. We have the average gold values and the sample type. The average gold values is numeric values with decimal places, so it's a real field, and the sample type is a character field. That's alphabets and numbers stored as text, but here we have only alphabets. Beautiful. So I will enter AU average ppm. Then I'll add another field, sample type. Okay, then I'll change the type of field to suit what I have in the CSV. So well, I'll enter a longer character length of 20 to be on the safer side. Okay, it's AUAV, so let me edit it. Alright, then I'll choose the missed case for the sample type. Now the low bound and the high bounds for the assay. It is recommended that you go through your assay table. If there are negative assay values that were reported, you enter a low bound of negative, high negative value, so that you will not have problem loading your database. Okay, so we go straight to the geology table. Here I will enter 30 as we did 30. As you can see, the box for the null section has been checked for the sample ID, telling Surpac that if we do not have a sample ID in our geology database, it should fill that field as blank. Alright, let's look at our geology table. We do not have a sample ID, so it has been checked. Perfect arrangement by Surpac. So we will not worry ourselves with the length. Then I'll enter 15 here. We do not have the coordinates. That's why we chose calculated. So I'll check the boxes for the coordinates. Then I'll add the other fields to the optional fields section. Looking at the geology table, we have redox and lithology. So I'll bring them to the optional fields section. Redox. Then I'll add another field, lithology. Let's look at what type of fields that they are. Redox is a character field. Lithology is also a character field. So we will maintain the character. Then I'll enter a longer character length to be on the safer side. Then I'll maintain the case type as missed. Alright, so we are done with defining all the fields for the tables. Beautiful. So I'll click apply to create the database. And when this is done, the name that we gave it was database. It will be shown in the status area and go into our work directory. Beautiful. So this is it. We have new database. Okay, so new database has been created. The .ddb is the file extension for the geological database, and the .mdb is the file extension for Microsoft Access database, and that is what is going to contain our actual drill hole data. The .ddb is the file that Surpac requires only to connect to the database, so we should take note the difference. So I will drag the Microsoft Access database into graphics for us to view the content. So as you can see, when I open the tables, we do not have any data in them. All right, we have just created it, we've not imported the data. Okay, so to view the content of the geological database file, you right click on it and select edit. And in this file, the first line gives the name of the database, and we gave it new database. And the type of database is also shown here. We chose general access, even though we had several options to choose the type of database that we want. The third line refers to the file path or directory of our work folder, and these are the tables that we loaded our database from. The color table, these are the characters, the length of the characters 30, 15, decimal places of 3. Our rate is Erwin version 8, a relational database model that Surpac also uses. The SSI is the file extension for styles file. Then the low bounds and the high bounds are all here. All right, we also have the survey table here. We have the translation table also here. All the tables are here. We have the assay table, we have the geology table. Okay, so we are done with creating the geological database. So all that is left is for us to import the data that we have in the CSV into the Microsoft Access database, which will contain our actual drill hole. All right, if you want to view the drill holes, you can just go here and select drill holes. But because we do not have any data in the Microsoft Access database, we've not imported it yet, no drill holes will be shown. All right, so we will import the data from the CSV files into the Microsoft Access database, and we will do that in our next lesson.